My name is Elmer Sum. I'm with Simon Fraser University, as well as with the Vancouver Greentech Exchange. Vancouver Greentech Exchange is a forum where we bring together several communities. The communities include the investors, the service providers, the entrepreneurs, and the academics.
So I work for the Ocean Renewable Energy Group, or OREG. We were formed in 2004 as Canada's Ocean Energy Sector Association. So we're a nonprofit association that advocates on behalf of the industry and works with government and utilities across Canada on advancing the sector. We differentiate ourselves a little bit by saying we're a sector association instead of an industry association because of that collaboration with government and with utilities. We were formed out of partnership arrangements with government's utilities from the beginning, so we're not a lobby group necessarily, and we do consider ourselves quite collaborative. So what is ocean energy? When I'm talking about ocean energy, I'm talking about using ocean waves, tidal currents, and tidal height differences, as well as rivers, in-stream water flows, so all man-made and natural in-stream water flows, for things such as generating electricity, for using that energy and power to desalinate water, hydrogen production, or pumping water. So that's the general realm that we're looking at. The International Energy Agency does have a working group on ocean energy, and member countries come from around the world. There are hundreds of patents and designs out there for different technologies. A number of these have gone to demonstration project stages, and just a handful have actually been built at full scale and have gone into the water for testing. So a lot of these technologies, they look very different. So at this point, it's not like wind energy where you're going to see a single design that's commonly used for commercial projects. So there's a number of different designs, and we don't believe that there's going to be a single design such as wind energy. You could have different devices for different locations, different resource and geographic environments. There is a significant industry around the world for ocean energy, in the way that there's a lot of activity for companies with technology development, and significant in the size of the resource that's available. But we are at an early stage. There's a number of sustainable development opportunity and benefits that can come from ocean energy, including the greenhouse gas emission reductions. And we can have Canada as a world leader in this industry. We have a number of companies that are working on technologies, so those technologies can be developed and exported around the world for use in projects, but we also recognize that we need to build the full supply chain for ocean energy, so having companies from resource assessments all the way up to actually project development opportunities and activities, and that expertise and our research expertise can also be exported as knowledge capital around the world. But we do need continued support financially and through opportunities to actually get these technologies moving forward.
Hi, I'm Nigel Protter, and I'm one of the founders of SyncWave Energy Inc., and also a co-founder of OREG, the Ocean Renewable Energy Group. Well, what we want to do is foster scientific research, certainly, for the components, but we also want to build together consortia of companies that can do all the pieces that are required. Ocean energy is not just about devices, it's about infrastructure, it's about expertise, it's about assets like ships, tugboats, vehicles, testing facilities, cables, subsea collectors, and so on and so forth. There's a lot of pieces to the puzzle. What drives me with wave energy is that there is not enough terrestrial renewable capacity to make a big dent in global energy. Today, about 2% of global energy is certifiably renewable. About 18% is hydro, which is not certified, large hydro, not certifiably renewable. That increment will not change very quickly going forward, okay? Wind farms are being built at a high clip, but they're being outpaced by the construction of coal plants today. And in fact, there is not, due to permitting hurdles, NIMBYism, environmental issues, all kinds of issues, we will not see a deployment, we will not see a meaningful increase in the amount of renewable energy on terrestrial sources. The answer to our energy challenges lie in the ocean. Global energy today is 15,000 terawatt hours per year. There's easily 50,000 terawatt hours per year of wave energy available. Can we harness it all? No. But we can harness a big piece of it.
As Tyler mentioned, the title of the talk is Harnessing the Power of Wave Energy Converters. My name is Brad. We'll go on a first name basis tonight. From the collection of letters after my name and the various titles I hold at the institutes I work in, you should get the feel that the numbers I'm going to talk about today are not going to have dollar signs in front of them. They will have kW, meters, kilograms, tons at the end. I'm going to speak about some of the technical aspects and the mechanical engineering and the systems integration work that's going on with a cluster of wave energy conversion researchers and developers. In terms of the hats I wear, there's a few. I'm housed, or my home is at UVic. This will be the only time I mention the name of my institution. The research institute there that I'm a part of is ICEVic. It's the Integrated Energy Systems Institute, which naturally lends itself to work in renewable energy technologies. And the other hat I have is with SyncWave Energy, or SyncWave Systems, and I work as the Senior Technology Advisor for SyncWave in their pursuit of a fairly innovative wave energy converter. The title was Harnessing the Power of Wave Energy Converters, and I don't know if you caught the twist on that. It's actually the title of an article my students and I wrote for a magazine actually a while back. Wave energy converters typically harness the power of the ocean. And there was a question earlier. In fact, there was a number of really good questions, and not less bit of discussion is probably going to change the tact I take as I move forward here. The question was from Tyler, was talking about, is there a correlation between where the best energy is and where you have the most difficulty putting the technology because you're dealing with a ferocious environment that's very energetic? And the answer is yes. And hence, wave energy converters by design, because they're made to work in this relatively ferocious environment, tend to be very big and relatively ferocious. And in fact, if you look at the names of them, they're actually drawn from old names of Greek sea monsters, or Katia. I always like to talk about this. Wave dragon, Palamus, and you get these visions of Greek heroes with swords and winged beasts flying through the water or over the water. The counter to that argument is there's also devices called oyster and limpet and clam, but I don't bring that up when I talk about it. So ferocious machines, ferocious environment. One of the other questions was from Klaus, and he asked about the difference between ocean energy and wind energy, and why is wind energy so advanced? And I think the short answer to that came from a poet who died a long time ago. And he defined ocean as a body of water occupying about 2/3 of a world made for man who has no gills. We don't do well in the environment where we're looking to install these devices. We don't do as well there as we do on land. And in terms of developing an innovative technology, if you want to do iterative testing, there's a big difference between installing a gigantic tower in a field where you can walk every day and put a turbine at the top, and you can take that turbine off every day if you needed to, and being able to duplicate that infrastructure offshore, where we don't do as well and we don't have the same facilities. And even when we get into test tanks or pools where we test scale models, we don't have many of those facilities. In Canada, we have a cluster of test facilities on the East Coast. We don't have a lot of them here. So in terms of the iterative development, which is everybody knows is part of best practices design, you learn from your failures and you move forward, it's hard to do.